Solving quadratics, part 3. Completing the square. Our objective this time is to look at the method of completing a square and to use it to factorize a quadratic and hence to go on to solve the quadratic. For support, you might look at pages 431 onwards in your textbook. Now, it's not always possible to solve a quadratic equation by the methods of factorization that we've studied so far. Fortunately, there is another method that we can adopt to help with this problem, and that method is called completing the square. A quadratic that will form a perfect square is of the form x squared plus 2ax plus a squared. Why is that a perfect square? Well, you can show that that is equal to x plus a squared. In this case, the x plus a squared is the perfect square. This perfect square actually does give us two solutions. It happens to be the same solution, x plus a times x plus a. It's possible to adjust a given quadratic expression to write it in the form of a perfect square. To do this, we would write it in the following form: x plus a all squared plus b. In this case, the x plus a squared is the perfect square and the constant is the b. Now, this is probably best explained by way of an example. So let's take an example like x squared plus 12x plus 40, and we'll now have an attempt to factorize this using the method completing the square. So to the whiteboard. Now, to solve this expression, or to factorize it, we need to look at this last number first. And this 40 is very close to a square number 6. 6 squared will give me 36. Now, the nice thing about 36 is, because it's got two 6's involved, I've got a 6 times a 6. But a 6 plus a 6 will also give me the 12 that I need for the number of x's. So it does look like 6 is going to be part of my solution, and it should look like something like this. X plus 6 squared will give me x squared plus 12x plus 36 if you multiply out. That's good. I've got a common term there, I've got a common term there, but I'm 4 light as far as the 40 is concerned, so I'm going to have to add 4 to my solution. So my solution then will be x plus 6 squared plus the 4 that I'm light to give me my final answer. Let's try another problem. Question 2b part 1. X squared minus 6x plus 10. We've got to factorize this expression. We'll start with the 10 at the end here, and note that 10 in terms of squares is very close to 9, which in turn is 3 squared. Obviously, with the 3 and the 3, I could get 6, because 6 is equal to 3 plus 3. Or even better, minus 6 is equal to minus 3 and a minus 3, which will help me get to this minus 6 here. So I think I might have a solution in the form of x minus 3 all squared. Let's multiply this out. I'm going to get x squared minus 3x, another minus 3x, and a plus 9. I'm short by 1. Compared to this 10 here, I'm short by 1. So I have to add a 1. So my solution now looks like x minus 3 all squared plus 1. I finished. Finally, let's try question 3 part A. X squared plus 6x minus 15. Again, I'm going to go for this number at the end here. I'm going to look for something that I square to get me to 15. Now, your first thought might be to go for 4. 4 squared will give me 16. That's pretty close. That gives me two 4's, but it's very difficult to use those two 4's to get a 6x. No combination will do that. So what I'll try instead is back to my 3 squared. In other words, 3 and times 3. I've got two 3's there, so those 3's together, 3 and a 3, can give me the 6. So it looks like my solution is going to be x plus 3 squared to give me the 6x. I'll multiply that out. I'm going to get x squared plus 3x plus 3x plus 9. But 9 and minus 15 are very different. I need to take something away here. I need to take away minus 24 to get back to minus 15. So my solution now looks like x plus 3 all squared minus 24. I've completed the factorization. Now for something a little bit more challenging. I've got an expression 3x squared minus 12x plus 8. And what makes this different from ones we've seen before is that the coefficient in front of the x squared is not a 1. It's 3 in fact. Now I need to reduce that down. And I can do that if I notice that the numbers in front of the x squared and in front of the 12 have a common factor. In this case 3. 3 will go into 3x squared times, and 3 will go into minus 12x minus 4x times. So I can rewrite this whole expression as 3 into x squared minus 4x plus the 8 on the outside. Now I'd like to turn the x squared minus 4x into a perfect square, and I can do that if I realize that this 4 here is actually 2 squared. So I'm going to take my chances and put a 3 in there with a bracket x minus 2 and then the plus 8 out here. I'll close this bracket off. Now I'm going to square that to get my perfect square, but if I multiply that bit out, I'll end up with x squared minus 2x plus 4. I'm ending up with 4 too many. So to get rid of that excess 4, I have to take 4 away. Now if I multiply through, I'm going to get the 3 multiplied by the minus 4 to give me minus 12, plus the 8 on the outside will give me minus 4. So my final expression is going to be 3 into x minus 2 all squared and a minus 4. And that is my factorization done. Now let's take this last example and imagine it not as an expression but as an equation. So I'll make this equal 0. But of course we've rewritten this in a new form, so we can make this equal to 0 in its new form as a completed square. Now I'm going to rearrange this equation to solve for x. So first of all we need to get rid of the 4 by adding 4 to each side. So now we'll get 3 into x minus 2 all squared equals 4. Now I want to get rid of the 3 by dividing both sides by 3. So we're going to get x minus 2 all squared equals 4 over 3. Now we get rid of the power of 2. We're going to take the root of both sides. So we get x minus 2 equals the root of 4 over 3. And finally we get x equals 2 plus or minus, because when you take the root of something it can have a plus or a minus result, 4 over 3. I got that by adding 2 to both sides. So I've got two possible solutions. What are they? So let's work out the root of 4 divided by 3. Shift root 4 divided by 3. We get 2 root 3 over 3, or in decimals 1.1547. So I'll write it down as 1.547 and I'll round it up to 3 decimal places in a minute. So x is either equal to 2 plus 1.1547 or x is equal to 2 minus 1.1547. X is either equal then to 3.155 rounded to 3 decimal places or 0.845. There's my two solutions.